Hello. In last lecture, we completed with the placement of our component and we have also set the design rules for our board or PCB layout. Now in this lecture, we'll start with routing. Routing means connecting these yellow lines with the copper track. Now in free version of Eagle software, we can do routing in two layers. One is top layer and one is bottom layer. For our board, we'll do most of routing in top layer and little bit routing on bottom layer. Now to start with routing, first we need to change the grid. So click on grid. Initially is 25 mil. 25 mil is grid is used to do placement of component, and for routing we'll select 5 mil grid. Click on OK and click on this option to start routing called as route airwire. So click on this and all the properties related to this route option will be available here. For example, we can select different width. Right now I have chosen the 40 mil width because this is power supply board and we want it to work without any problem. So we'll keep track width little bit thicker. Bend stand will be 45 and click on this option, push obstacle. Now let's start with routing. So first we'll connect this all ground pads together, and if you click on pad, you'll see all the ground pads are highlighted now, so it helps while doing routing. So click on this pad, click, click, and try to do this routing from the center of pad, exactly from this center. Now we'll do this V-in connection. So click, this is also connected to this first pin of regulator. So click, click. Now I will make this connection, second pin of regulator to this diode, but I think there is little bit less space for drawing the track. So let's move this diode little bit. So again change grid to 25 mils. Click on move. Click on diode. Move it below it little bit. Now again change grid to 5 mils. Click on route airwire and start drawing this track. Click at the center of pad. Click again. And click. We can also move the track if we want. So click on move. And from here we can move the track. Now let's connect these ground points. So click, click and connect it exactly straight. I'll again connect this fifth ground point. Click, go up and connect it. Now we'll connect. We can see if we click on rack nest, this second point is also connected to here. So we'll extend this track to this inductor. Click on route, click, So as we set at the design rules, this track is not able to go from here, so press escape. And if you want to delete any track from your layout, click on this option called as rip up. Click, 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 and we'll shift this diode little bit up. So set grid to 25 mil. Click on move, click on this diode, move it little bit up and right. Click, set grid to 5 mil again. Click on root and join this track again. And now let's join this one. So click, click. Now we can go. Click, click, click. Join this track. Now this one. So click. This is also connected to this capacitor, so click on center of capacitor. Escape, Control Z, and again start. And now this last one. And save it. So we have done routing of all the tracks. So this is the first phase of doing the layout, where we connected every pad or we connected every track to each other. Now as this is power supply board, this board will carry more current. So what we'll do, we'll not leave these tracks as it is. We'll convert this track into polygons. So basically polygon is a patch of copper or area of copper which will help to carry more current. If board is carrying more current, the patch will help to carry more current. So initially I will show you how to connect these ground pads from bottom layer. So first we'll make copper patch or first we'll draw copper polygon on bottom layer. So to do that, first we'll change grid to again 25 mils. Now to draw polygon, click on this polygon option. Change bend style to 90 degree. Click on this thermals off option. And now start drawing the polygon. So first we'll draw polygon for this connecting these mounting holes, and we'll place it on entire bottom layer. So don't forget to change layer. Select bottom. So click. So width is 40. I will change it to 8. Click. 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 And click. And once we complete the polygon, the eagle will ask you to which net do you want to connect this polygon. Now we want it connect to the ground net. That's why we have given name to every net in the schematic. So this is the name. So type GND ground and click on OK. Now this polygon is connected to all these mounting holes as well as these two through hole pad from the bottom layer. Now this is not yet poured off, or polygon is not yet placed. To place the polygon, click on this rat nets option and again go to top. So here you can see the polygon is placed, and this polygon is placed from bottom side. Bottom is the color used, blue is the color used for bottom, and all these ground pads are connected to this copper, and this entire blue area is poured with copper. Similarly, we will also increase the, or we'll also pour the copper, or we'll also place the polygon to this ground track because it is big, and we'll place it on top layer. So again, select polygon, change bend style to 45°, leave layer top only, and start from here. So click, make sure you are a little bit below to this pad of regulator. Click, click, go up, click, 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 escape, click, click, click. Again give name ground, click on OK. Now if you click on this rat nest, this polygon will be placed on top layer. See, and all the pads are covered with this polygon now. Similarly, we'll draw polygon for this V-in track. So click on polygon, width 8, bend style to 45, top layer, and thermos off. So we'll start from here, click, we'll go below till here. Now here polygon is not adjusting, so we'll change grid to 5 mil again. Okay, click, and we'll try to cover this complete pad. Click, click, go up and complete this. Now this is the name we have to give to this polygon, which is V-in. So V-in, click on OK, click on rat nest. So this is the polygon for input, and this is, we can see this is also connected to this input pad, this regulator pad. Now we'll draw a polygon for this track. So start from this edge of pad, click, 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 Now this is the by default name, which is $4. We'll give same name $4, but we can change this name also in a schematic. Right now we'll use this name only. Okay, and click on drag nest. Now we'll place Polygon for this 5-volt output track, because from this pin and from this track it will give the 5-volt output. So start with this edge of pad again, click, select Polygon, click, click. Now go straight, move up a little bit, click, click. We'll cover this entire pad. And give name 5-volt, 5V. Okay, zoom out and click on drag nest. We can also change the copper pore. If you want to change any polygon, any copper pore, click on move, click on edge of that copper polygon and move it. And click on drag nest again. So this is how we can modify polygon or shapes. So that's it. We completed our entire layout. So first we divided into two phases. In first phase we created or we connected only tracks, and in second phase we converted those tracks into polygons, because this is power supply board. Now save it. Now the next step in PCB layout is doing design rule checking. Means checking the board that is correct or not as per our design rules. So before going to that, I would like to show you one option in Eagle. It is layer setting. So click on this layer setting option, and using this layer setting option we can hide or unhide different layers. So if you want to hide this top layer, entire red region, you just click here in front of this track top. Now the top layer is hidden. Similarly we can hide the bottom, and these are the outlines of components which comes under T place. We can hide that also, and these are T names. So by using this layer setting option we can see different layers. This is also helpful if you want to see only single layer. If you want to see tracks on top layer, disable bottom, and if you want to see tracks on bottom layer, disable top. So this is helpful option which helps for viewing different layers. So click on OK. Now let's do design rule checking. Before that, save it again. Now to do design rule check, expand this menu and click on this option called as TRC. Again this window will open up, and here we have set different rules. So click on check, and at this left bottom you can see it's showing there are no errors in the board. So this board is now good to go for manufacturing, and in the subsequent sessions we'll see how to do 3D rendering of your board and how to generate manufacturing outputs. So that's it for this lecture, and I will see you in the next lecture. Thank you.